Hello everyone, I'm Hsiao from National Taiwan Ocean University, and this is pleasure to attend the PICES 2021 and had a presentation here. Today I want to talk about the climate-induced fluctuation in primary production required in summertime upwelling ecosystem around the Taiwan Bank. And we know the primary production is important in the biogeochemical cycle, and it is the basic energy in the ecosystem, and which is transferred to the entire ecosystem through the food web. And the certain PP it can be supported at a certain amount of fishery catch. So on the contrary, the certain catch requires a certain primary production to support it in order to balance the operation of the ecological food chain. So based on this concept, we can converting catches to the equivalent primary production, which can be regarded as an indicator of the environmental tolerance. So my study area is in Taiwan Bank, which is located in the southern Taiwan Strait, and it's being affected by the China Coastal Current, South China Sea Warm Current, and the Cross Branch Current. And in the summertime, the surface current will caused by the wind driven, and the bottom water flow will upward along the edge of the continental shelf, and forming an upwelling region, and which is an essential fishing ground. And the upwelling area usually has a low SST, high chlorophyll A, and high primary production. From the previous study, we know that the Taiwan Bank can be divided into different ecological habitats such as upwelling area, front area, and so on. Different habitat ecosystem will have the different species composition and energy transfer. Kyoto 2020 know that in the Humboldt upwelling ecosystem, due to the high primary production, the biomass of the anchovy, sardine, and other low tropical level species is abundant. And in the Eastern tropic Pacific ecosystem, the primary production is relatively lower than the distribution of the species in each trophic level is more even. And just as 2010 analyzed the whole marine ecosystem around the world and found that the transfer efficiency is different in tropical temperature and the upwelling area. And otherwise, climate change also will affect the ecosystem. And LAN 2014 point out that the catch of the mullet in the Taiwan Strait is relevant to the ENSO event. Overall, Taiwan Bank are an important fishing ground due to the upwelling, which has led to a high primary production, and there are different ecological habitats, but few studies related to the composition structure of the species between each habitat. Also, the offshore fishery in western Taiwan have been declined years by year since the 1980s. And the relationship between the climate change affecting on the marine environment and the fishery production is unclear. So we want to know the first, the marine environment variation of the Taiwan Bank. Second, the variation features of the species composition in each ecosystem. Then third, the effects of the climate change on whole ecosystem. And right side, you can see is my research process. And in data collection part, we collect the fishery data and the environment data from the 2011 until 2016 and June to September in Taiwan Bank area. So fishery data is combined two kind of the data. The first is fish logbook data and the second is voyage data recorder and with the 0.1 spatial resolution. And environment data we use SST and MPP from the satellite data and the three different kind of the climate index, the PDO index, MEI index, and the WPO index, according to our research areas. Then we calculate the primary production required, which calls PPR, using the formula above, and also According to the characteristics and the life strategy of the species, we divide into the pelagic PPR and benthic PPR. And to estimate the upwelling intensity, we calculate the upwelling area based on the SST upwelling index, and we grade all data into 0.2 spatial resolutions and classify the three habitats, which means the upwelling habitat and front habitat and non-upwelling habitats. And finally, using GM model to base on our three habitats and the two kind of the species, we build 6 different models. The optimal fitting models were selected through the stepwise procedures based on the minimize the AIC value. Result part. The spatial distribution of the monthly average environment factors can show that the SST was lower and the upwelling size and the MPP were higher in the June and July than in August and September. 3 areas has the different changing pattern and upwelling intensity. The lowest the SST, highest MPP, then higher upwelling intensities in the upwell area. And species composition. In Taiwan Bank, the benthic species take 20% of the whole PPR, and mainly for the moonfish and the squid and the hairtails. And pelagic species provide around 80% of the primary production required, and mainly by crombride, most is spot chop mackerel, and Japanese horse mackerel, and Pacific round herring. So, we also found that the different species composition in 3 habitats. And we also can see some difference in the spatial distribution about the PPRs. The pelagic PPR was highest in the north part of the upwelling habitat and the front habitat, and also highest in the southeastern part of the non-upwelling habitat. But the benthic species only highest in the upwelling and front habitat, and less in non-upwelling habitat. In whole 6 models, highest the deviance explained is in the benthic PPR in front habitat takes 28.5%, and lowest in the non-upwelling benthic PPR only took 8.9%. And all benthic PPR models shows that the MPP is the most effective factor in the benthic species PPR in all 3 habitats. And the partial residual plot shows that they are positively relation. On the other hand, the pelagic PPR was mainly affected by the climate index, and the partial residual shows that they are negatively relative. Meanwhile, the SST, MPP, and upwelling intensity also affect the pelagic PPR variations. Furthermore, we check the difference of the space distribution of the sea surface temperature, primary production, and the primary production required between the La Nina and El Nino years. The positively pelagic PPR, positively MPP, and the negatively SST was showed up in the same area. And variations in the spatial distribution of the PPR of the benthic species were not associated with the environment factor during the ENSO event. The variation of PPR in 3 habitats is influenced by the different marine environmental factors. Based on our GM result, the MPP was highly affected the benthic PPR, but from the monthly time series, we can see MPP peaks in June and decreases gradually through September for both species type of all 3 habitats. Whereas, monthly PPR increased gradually from June to August. This result indicates that the relationship between PPR and MPP maybe have a time lag about 1 month. And this is because the whole process of the energy transfer takes time. From zooplankton bloom to a high consumer increase, they are layers by layers. On the other hand, the pelagic PBR was mainly affected by the ENSO event and upwelling event, and during the El Nino event, the upwelling decreasing, the catches of the scombi species decreasing. However, catches of the low tropical level species such as the Pacific round herring and the sardines will increasing, and cause the species a pelagic PPR state the trend of the decline. Summarized. In La Nina event, upwelling enhanced and SST decreased, MPP increased, and the PPR increased, and vice versa. And second, the variation of the species composition is caused by the proportion changing between cold water pelagic species and the warm water pelagic species due to the ENSO event. So, conclusion and the future research. The variation of the PPR in three habitats is influenced by the different marine environmental factors and affected by the climate change. The El Nino and La Nina events have different upwelling intensity to drive the environmental change so that species composition change. In future research, the performance of the model was further analysis and evaluated through different regions classification and compare the analysis with the EcoPath with the EcoSym model. And study periods should be extended to facilitate the follow-up study. Thank you for your listening.